A backward curved impeller looks simple after assembly: a hub, one or two plates, and a ring of formed blades. But its performance depends on geometry that must survive every manufacturing step. This Longwell product footage shows the finished geometry only. It is not presented as footage of forming, joining, inspection, or balancing. There is no single process for every backward curved impeller. Material, diameter, production volume, joint design, speed, environment, and drawing requirements determine the route. This film follows a common fabricated metal route. Molded plastic, composite, cast, or other designs require different controls. The manufacturing traveler begins with the released drawing revision and the specified material. Blade blanks, backplate, inlet plate, and hub features are nested in cut. Identity must follow the parts, material grade, thickness, heat or lot where required, orientation, and drawing revision. A beautiful blank with the wrong identity is still the wrong part. The flat blade is formed to its required curvature and, where the design calls for it, twist or changing section. The important idea is not the name of the press. It is datum control. The surfaces and edges used to locate the blade later must remain repeatable. Tooling, springback allowance, edge condition, and periodic checks keep one blade from drifting away from the next. The hub and backplate are located from a common reference axis. Concentricity starts here, before the first blade is installed. If the hub is offset, or the plate is not seated correctly, later balancing may reduce vibration but cannot restore the intended airflow geometry. An assembly fixture controls the blade pitch circle, count, stagger angle, edge height, spacing, and rotation hand. The blades are loaded in a defined order and checked before permanent joining. This is where the aerodynamic drawing becomes a physical rotor. Small setup errors can accumulate around the circumference. The specified design may use welding, riveting, brazing, mechanical locking, adhesive, or another approved method. These methods are not interchangeable. For a welded construction, heat input and joining sequence matter because uneven shrinkage can distort the plates. The traveler should record the applicable procedure and inspection status. This animation does not claim a particular joint method for every Longwell impeller. Before dynamic balancing, inspect the physical geometry. Typical checks may include axial face runout, radial edge runout, hub concentricity, blade height, and joint appearance, according to the drawing and control plan. Balancing a rotor with a loose joint or excessive geometric error treats a symptom, not the cause. The assembled rotor is mounted in the specified orientation on a suitable balancing machine. The machine measures residual unbalance and indicates a correction location. Material is then added, removed, or otherwise corrected only by an approved method, followed by another verification run. The acceptance value, operating speed basis, and correction method must come from the product specification, not from a generic video. Cleaning, corrosion protection, coating, passivation, or another finish follows the approved route. Fit surfaces, drainage features, holes, and electrical or identification areas may need protection. Finishing must not conceal cracks, poor joints, blocked openings, or an incorrect assembly. Identity remains with the rotor through the process. Final release links the physical impeller to its records, part and lot identity, drawing revision, material status, key dimensions, runout, balance result, joint and appearance inspection, finish status, inspector, and date. The exact list is product specific. The point is traceability. Every release statement should point to a controlled requirement and a recorded result. The finished backward curved impeller is more than shaped metal. It is a chain of controlled geometry, identified material, repeatable forming, common axis fixturing, design-approved joining, runout inspection, verified balance, and final release. That manufacturing record is what lets engineering and purchasing teams evaluate more than a product photo.